So today we're going to be looking at inequalities, which is unit 22. So firstly, what are inequalities? Let's just quickly go through. Basically, if something is anything that's not equal to, so when something is less than, more or greater than, at most, which is the same as less than or equal to, at least, which is the same as greater than or equal to, and then we can even have not equal to, although we don't tend to see that at GCSE. At least we don't have any problems with it to deal with. So these first four are the ones that we see a lot of at GCSE, and let's just have a look at the symbols for them. So we should be familiar with these already. The symbol for less than just looks like this, okay? And more than then is the other way around. So, example there, we've got 2 is less than 3. One way I always just say to remember is the crocodile's mouth opens at the bigger number. Some people remember that way. More than then, so here we've got the more than symbol. So there's an example, 3 is greater than 2. At most, that means less than or equal to. So x is at most 10. It cannot be greater than 10, but it can be equal to 10. So you'll see there that this is the less than sign, but with the equal sign joined in on it there, okay? And then we've got at least, so greater than or equal to. So we could have y is greater than or equal to 0, for example. Just y is a number that is either 0 or greater. I'm just going to mute. Does anyone have any questions? Just going to mute you there. Okay. Please do feel free to unmute yourself. If you've got any questions, just press unmute and ask, or you can pop it in the chat. I will keep an eye on the chat there. Okay. And then we also have this symbol, which people tend to be less familiar with, but it's quite easy to work out, not equal to. So anything, if it's not, it cannot be equal to a number, we see that symbol. And we'll come back to this when we do graphs, because this is most commonly seen when something cannot be equal to a number with graphs, okay? So let's, there we go. 2 is not equal to 3, for example. Okay. So inequalities can be represented on a number line. So here we've got a number line. And if I want to represent the inequality x is greater than or equal to 1, I'm basically going to find the number 1 on my inequality. And I'm just going to draw an arrow going in the greater than direction. So all the numbers greater than 1 are anything that x is greater than or equal to 1. And one thing that I want you to recognize and spot there is just that this is a filled in solid dot there, okay? So that just represents the fact that it is greater than or equal to. If, for example, we wanted the number or the inequality x is greater than 4, we'd find 4 and we'd draw the arrow again, but this time we don't have the or equal to. So this time we will not be filling in that spot there. We'll just have a hollow circle and the arrow in the greater than direction there, okay? Let's have a look at that then for less than. So if x is less than or equal to -2, we would find -2 there. We've got or equal to involved, so we need a solid filled in spot there. So we'd colour that circle in and then draw an arrow going off in the less than direction this time. And here we have one, x is less than 0. So do not colour the circle in this time because we want an open spot to show that it's less than but not equal to here. Okay. We sometimes have to represent what we call bounded inequalities on number lines too. Bounded inequalities are just where we have an inequality on both sides. So we're saying here that n is any number that can be between -5 and +5, and it could be including both -5 and +5 there. So basically just any number in between or including -5 or 5. And that also will include any decimal, any fraction, anything in between those numbers. So you'll see we've just drawn a line from -5 to 5, and we've filled in both circles because we have the or equal to on both sides there. Okay, so looking at this one, we only have the or equal to on this side with the 4. So n can be less than or equal to 4, but it must be greater than -1. So there we have an open circle at -1 and a closed circle at 4. So hopefully you're kind of getting the hang of this now. And then we've got n can be any number between -5 and 0. And again, both open circles there because we have no or equal signs on this one. Okay. And then one other thing you might need to do is to be able to actually write an inequality for yourself. So you might be given a number line. It's very rare, but sometimes in the foundation paper, you could be given a number line and you could have to write the inequality down. So if you're given a number line like this, you know that your inequality is bounded by the numbers 0 and 5. And because both of those circles are filled in, we want them to both be or equal to. So we've basically got a number, we'll call it n, is greater than or equal to 0 and less than or equal to 5. So it would look like this, okay? Moving on then, hopefully you can sort of look ahead if you want and just have a go at these yourself before I do tell you. But here we have n is going to be greater than -5, but less than or equal to 4. Okay, so you'll see we've got greater than, but no equal to on this side. But we've got less than and equal to 4 there. Next one up, we have sorry, I've given you the answer before I went through it there, but hopefully you'd got to it yourself. We have n is both as greater than 0 and less than 5, neither of them equal to there. And this final one, we should have it's greater than or equal to -5, but less than -3, okay? Can get a little bit confusing with negatives. And remember that obviously -3 is greater than -5. So it's easy to see on the number line, but sometimes people do get muddled up with those when working with inequalities. So just consider a number line if you need to for those kind of things. Okay. And does anyone have any questions on what we've done? Because I'm going to do a quick ABCD poll thing next. If you've got any questions, please do just pop it into the chat or unmute yourself and ask. No? Ready to do have a go at some of these yourself? I'm hoping that's everyone going yes. Okay, so here we go. We've got an inequality shown by this number line. Okay, is it A, x is less than 7, B, x is greater than 7, C, x is less than or equal to 7, or D, x is greater than or equal to 7? And I'm going to launch a quick ABCD, so you should have a chance to answer now if I've done this right. Good, lots of people answering. That's really great to see. Lots of answers coming in. My goodness. Almost everyone's answered very, very quickly. Well done. Great. And really, really awesome to see. 83% of you have got that correct. So well done. We have got the answer. X is greater than 7. So that one is B. X is greater than 7 there. Okay. Because we have an open circle there at 7. Everybody answered that, so everybody recognized the open circle, and then the arrow goes off in the positive direction, so the number is getting bigger than. And of course, remember the crocodile's mouth opens to the bigger side, so x has to be greater than 7. So let's try another one. Stop. There we go. I don't want to launch that just yet, do I? Okay, so this time we have got the number 5. In fact, I'm not going to read it out to you. You can see it. So I'm going to give you a chance to answer now. Is it A, x is greater than 5, B, x is less than 5, C, x is greater than or equal to 5, or D, x is less than or equal to 5? And we have got 100% of you answering already. 83% correct answer again. So well done. Really, really good to see. And the correct answer this time is we have a filled in circle. So it's either C or D. And we have it going off in the less than direction. So it's less than or equal to 5. So this D is giving us the answer less than or equal to 5. Okay. Just being careful with your inequality sign. Make sure you know that the smaller, like the open side should be pointing at the bigger thing. So the less than or equal to is on the D there, okay? Let's have one more go. So we have a bounded inequality this time. So I'm just going to give you a moment to have a look. Okay, hopefully that's enough time. Let me relaunch that and have a go. Ooh, we've got a lot of mixed answers coming up this time, so we might need to talk about this one. Okay, all right, I'll end it there as a couple of you haven't voted yet, but that's okay, you might be just unsure. So we will go through this because a few people are unsure about this one. So we've got the numbers 1 and 11 here, and we know that our number that is in like this number line has to basically be in between 1 and 11. And we know that it's not equal to, so none of these are actually equal to. So it's definitely going to be, well, I might even write this down just to help you annotate. There we go. So we're going to have 1 there. We're going to have X in the middle, and we're going to have an 11 there. Okay. So we just need to figure out which way around these inequality signs are going. Now, X has to be bigger than 1. Okay. It has to be greater than 1. So when I write my inequality sign, I'm going to write it with the bigger side of the inequality sign facing the X, because it has to be bigger than 1 there. But X also has to be smaller than 11. So I'm going to be writing it with my smallest sign of the inequality side of the inequality sign facing the X, so that it shows that X is less than 11 and 1 is less than X. Okay, so having a look through these, this one is essentially saying that 1 is greater than X and that X is less than 11. Okay, so that's not actually possible because 1 can't be bigger than 11. Okay, so that's actually an impossible one there. Here we're saying that X is greater than 1. So X can be greater than 1, but we're also saying that X is greater than 11. Okay, so that is possible, but that means that we would have this side. We'd basically be saying that X is greater than 1 and it's greater than 11. It's kind of an unnecessary thing to say, because if we know X is greater than 11, we don't need to say it's greater than 1. We already know it's greater than 1. Okay, so it's not B. And then here we have that X is smaller than 1 and that 11 is smaller than X. So we're essentially saying there that 11 is smaller than 1. So that's not possible either. Okay, so it had to be D there. All right. Hopefully that's helped. If you were a little bit unsure and you've got any questions, please do ask. Should we try one more? Okay, we'll try one more. We have got, oh, I can't tell you. Okay. All right, so hopefully you've had enough time to have a think. It's a bit confusing because they do all look so similar, don't they? There we go. Let's have a go. Oh, fantastic. We've just had 5 people put the correct answer in straight away really quickly. So that's really great to see. I'll just give you a couple of minutes for the last few people to join in. Anyone else that wants to join in? Okay. All right. And I'm going to end it there. Okay. So we have got X there. Good. X is in the middle. 1 is or equal to 1 there, but it's less than 18. So X is greater than or equal to -1, but X is less than 18. And almost all of you got that correct there. It was B, okay? So all of you gave me the inequality signs the right way around, so that's fantastic. I think just a couple of people forgot that or equal sign needed to be there as well, because this is a solid one. But it's really good to see that you've all got the inequality signs the right way around this time. So well done. And just want to point out, you can sometimes get them like this, where they are pointing off in different directions. So hopefully it's fairly obvious what this one means. I just thought I'd throw it in there as a guess. Choose your answer now, and I will launch that for you to have a go at answering. There you go. Ooh, we've got two competing answers this time. That's interesting. Some people are saying A, some people are saying D. Okay, so this, because we have got, I'll end it there so you can see. Okay, so a few different answers coming in. A few of you have got the correct answer, that's great. Because we've got two different inequalities, we are going to have two different things, okay? It cannot be D, because it's actually not in between the inequalities. So X is not in between 1 and 11, so therefore it cannot be D. Okay, so it has to be two separate things. So let's have a look at the two separately. We've got X here is less than 1, okay, and not equal to 1. Okay, so X is less than 1 could be either A or C. Oh no, I've just gone past it. I have to go back now. There we go. Oh, that it was A anyway. So X is less than 1 there, and then we've got X going off in the greater than 11 direction. But we have got a solid filled in 11 there. So it's got to be greater than or equal to 11. So that was just a little extra one I throw in there with 2 on the number line. Very rare, but you do see that on the odd occasion. Okay. So does anyone have any questions, or shall I move on to solving inequalities? Okay, I can't see any questions, so I'll move on. Right, so with solving inequalities, this is kind of where we're just going to actually be doing a bit of revision as well, because solving inequalities are almost exactly the same as solving equations. Okay, so we can review our solving equations today. The only difference is that you must use the inequality sign throughout. If you change it to an equal sign, you will lose the marks. And I've seen that happen in so many exams, and it's really sad because everyone's done all the maths right, but they've changed their inequality sign to an equal sign, and so they've lost the marks, okay? So don't do that. Yeah, it's really sad when that happens, okay? So if you see a question like this, solve 2x is less than 6, you can solve that in exactly the same way you would solve an equation. So how did we learn to solve that? Well, we would start by dividing both sides by 2. So we would have x on this side and then 6 over 2 on this side. But the main thing is that you must keep the inequality sign the same. So if you were to write now x is equal to 6 over 2, that would be completely wrong, because actually what this is saying is 2x is less than 6. So that means that 2x does not equal 6, it's less than 6. So our answer is that x then is less than 6 over 2, or less than 3, okay? So we use the same method, but we cannot put an equal sign in there. And it's really, really common in an exam to see people putting equal signs in there instead of the inequality sign. So just be really careful when you're doing your exam to make sure you don't do that, okay? So let's have a go at doing some. Just a quick review then. How do we do these questions? So x plus 3 is less than 7. Does anyone want to write in the chat what step I would have to take to solve this inequality? Excellent. Really quick. Well done. Thank you, Tabitha. So we're going to subtract 3 from both sides, and we'll have x is less than 4. Okay. And in exams, especially in the foundation tier exams, you'd quite often then be asked to represent that on a number line. So there's your number line. X is less than 4. You'd have to draw an open circle above 4. And then in the less than direction, you'd put an arrow there. Okay. Right, for the next one, we're going to have to do 2 operations to solve this. Does anyone want to put in the chat what those 2 operations are? Or you can just put them one at a time. Excellent, thank you. That's the first one there. So the first one is going to be to add 6 to both sides. So I'm just going to put the little note on the side, and we will have 2x is less than or equal to 2 plus 6, which is 8. And then divide by 2. Great. Thank you for putting this into the chat, doing my work for me. Really good to see. Okay, so now we've got x is less than or equal to 4. So once we've solved it, you may be asked to represent it on a number line. So you'd come over to your number line, find 4, draw a circle, make sure you colour it in this time because we have got an or equals sign, and then draw an arrow. Doesn't have to be neat, just has to be obvious which direction you're going in, and make sure it's going in the less than direction there. Okay. And we've got one more to do. Anyone else want to pop something in the chat there? Really good to see. Excellent. Thank you. A couple of people answering now. Okay, so let me get my different color. First step is to plus this 3. Plus this 3. 3x then is greater than or equal to 12. Next step, please. Thank you. Okay. No one else is going to answer. Okay, it's correct. Well done. So our next step is to divide by 3 because we've now got 3 times x. So we remove that 3 by dividing by 3. Divide by 3 on both sides again. X then is greater than or equal to 4. All of these answers are 4. I don't know why that happened. It just seems that that's how this has worked out. I must have just been thinking about the number 4 when I did this. So let's draw a circle. Let's colour it in because we have an or equals. And this time we want greater than. X is greater than 4. So we're going to draw our arrow in that direction. And as long as we put an arrow there to show that it just goes on forever. Okay. So that's how we solve inequalities. So the main thing to remember is that you just do not change those inequality signs to anything else, except for in one instance, which I will talk about next, or I'll talk about in a minute. But don't change it to an equals, whatever you do, okay? Any questions? Okay, hopefully that's enough time to write notes on that, and I'll move on. Oh, and there's the answers. So bounded inequalities, we've seen these a little bit. You can solve most bounded inequalities by just literally doing the same thing to each side, okay? So here we've got 2x is greater than 2, but less than 14. So I would solve this by dividing by 2, okay? So I can solve this by dividing every single bit by 2. And I will have 2 divided by 2 is 1, 2x divided by 2 is x, and 14 divided by 2 is 7. So basically, when they're simple like this, we can literally just look at it and we can often see, okay, I can divide everything by 2. And I've got an answer here. 1 is less than x is less than 7. Let's represent that on the number line. Find the number 1. There's no equals sign, so I'm not going to colour the circle in. Find the number 7. There's no equal sign, so I'm not going to colour the circle in, and then draw the line between them there. So let's have a look at this. Okay. So hopefully it's fairly obvious here because we've got 3x here that we're just going to get to x by dividing everything by 3. Just as though if we had the equation with this part on this side covered up, 3x is equal to 18, we would divide by 3. Or with the other side, only this part, we'd have 3x equals 30, we'd divide by 3. So we could do this separately if we wanted. We could take both sides and do it separately and put it back together. But I don't think we need to at this point, okay? I think we can just solve this as we see it. So hopefully you've done that in your head, and hopefully you've got 18 divided by 3 is 6, less than or equal to, don't change the sign, 3x divided by 3 is x, less than or equal to, and 30 divided by 3 is 10. So if 3x is between 18 and 30, x has to be between 6 and 10. And I think we will have a number line come up. There we go. And we've got the or equal sign, so the circles are coloured in there between 6 and 10. Next one, we have got 2x this time, so we're going to solve by dividing by 2. So 10 divided by 2 is 5, is less than 2x divided by 2, which is x, and 38 divided by 2 is 19. Okay, I really hope. Let's check. There we go. Okay, so this time we have an open circle at the 5 and a closed circle at 19. And here we have, oh, slightly more complicated one, but we can do exactly the same thing. We're just going to have 2 steps to this one. So we'll use a different color just to show the 2 different steps. First step, hopefully you'll recognize exactly the same as solving any normal equation. We're going to subtract the 1 from both sides. Okay, so we're going to have to do it to all 3 of these now. So we're going to do 9 minus 1, which is 8, less than or equal to 2x. That 1's gone away because we've taken it away, and it's less than 32. And then we're going to do the next step, which is dividing by 2. I forgot to change my color, so it didn't really help, did it? Sorry. And again, we have to divide everything by 2. So 8 divided by 2 is 4, less than or equal to x, and that's less than 16. Okay, so there's our answer. And again, we can represent that on the number line there. We've got 4, and it's a solid circle for the equal sign, and 16, and it's a not solid circle because it's not got the or equal sign on, it's just the less than. Okay. Anyone got any questions yet? I will continue. Okay, so let's have a look at solving an inequality, a slightly more complicated one, because this time we've got x on both sides. So they are getting a little bit more complicated. But again, no need to worry. It's exactly the same as using the skills for solving a normal equation. We're just going to keep that we're going to keep that inequality sign as we work through. So remembering my number 1 rule for x's on 2 sides, does anyone want to tell me what the first step for this will be? There are a couple of different things you could do here. So like you've got a few options, but I tend to have my hint, if anyone remembers what my hint was, to move which first. It doesn't matter if you don't get it right. Have a guess. Okay, no one's giving, okay, no worries. I will just say, so my hint was to always move the x with the lower coefficient first. So out of these 7x and 4x is the lower one. So when we're solving any equation or inequality or anything like that, if you subtract that first, it means that you normally don't have to worry about negatives, okay? So by subtracting that, we have got 7x minus 4x, which is 3x. Everything else stays the same. We've got the minus 3 still there. We've got the less than or equal sign still there. And we've got the plus 3 has just become 3 here, okay? So the thing that's gone is this 4x. It's gone from both sides. What's the next step going to be? There's only one logical step. Excellent. Thank you, Meadow. We have got to add 3 to both sides. So I'm going to add 3 to both sides, and we're going to have 3x is less than or equal to 6. And my next step, please. Divide by 3. Thank you, Tabitha. Well done. Okay, so we've got x is less than or equal to 2. So from there, you all seem really confident. Don't forget then, you could actually have got here other ways. You could have added the 3 first, but by subtracting the 4x, it just makes it into that lovely equation that we're used to solving. So just that's the hint, really. Move that out of the way first, okay? Representing that on a number line, then we've got x is less than or equal to 2. So we're putting a solid circle at 2 with an arrow going down. It doesn't really matter if you draw it on the number line or a little bit above. I tend to draw it a little bit above just because it's easier to see. So I would have probably gone like that. But you see different things in different textbooks and mark schemes, so it doesn't matter too much as long as you show the right direction. Right, I think we are good to go on to that one exception that I did mention earlier. There's one exception for this rule of don't ever change the inequality sign. And that is when we multiply or divide by a negative number, which is a rare thing to have to do, but you do have to do it sometimes. Let's have a look at what happens if we look at this problem here. So imagine if I've got this problem, 26 minus x is greater than 20. And there's a couple of things I could do to solve this. I have two options really to do first. I could either start by subtracting 26 from both sides, or I could start by adding x to both sides. And I want to have a look at what happens if we do both of those things. So let's first of all just imagine I add x to both sides. So I'm going to add the x to both sides. And now I'm going to have 26 is greater than 20 plus x. And I haven't actually managed to get my numbers on one side and my x's on the other side yet, but it looks nicer because I haven't got a minus x here. So the next step would be, I'm just going to change that into black so that it's a bit clearer. So what have we got there? 26 is greater than 20 plus x. So my next step now, because I want x on its own, would be to subtract 20 and to subtract 20. And so you can see now I have 6 is greater than x. And I've managed to solve this. I now have the answer, and I've done it without changing the negatives, the inequality, and I've done everything correctly here, okay? But what you'll notice is the x is now on the other side. So rather than having x on the side bigger than, I've now got x on the side smaller than. So because this x is now on the other side, I can actually, if I wanted to write x here, I would have to write x is less than 6. These two things are the same thing. 6 is greater than x, or x is less than 6. So you'll see that what's happened is this inequality sign from where it started to where it finished has actually flipped over. And let's have a look now at solving that exact same problem. 26 minus x is greater than 20. But instead of adding x to start, sorry, did someone have a question? No? Okay.
Yes.
Oh, you do?
How did you get that sign to be changed from where you started off with?
This sign from changing from here to here?
Yeah, because I work it a different way and I got x is greater than 6. So I don't see where you get that x.
Okay, so the reason why the sign has flipped is because I actually moved my x to the other side first.
That's on one side.
Sorry, say that again?
Greater than minus 26. So you'd have minus 6. Minus x greater than 6. And then to get rid of both minus on each side, 6
You're breaking up a little
is
bit.
greater than 6.
I think that's the method I was just about to show you here, actually.
My internet here is not good at all.
Yeah, let me show you because I just think you're breaking up a little bit, but thank you for pointing that out. Yes, so I was just about to show you the other method here. So what I could do instead is I could subtract 26 instead here and here. And if I get rid of this 26 by subtracting 6, I will then have minus x is greater than 20 minus 26, which is minus 6, which I think is what you were saying there, Winston. So now I've got minus x is greater than minus 6. And that means that I need to know what x is. Now, if minus x is greater than minus 6, x must be less than 6. Okay? If we just think about how that works, imagine x was 3. Okay? Or actually, yeah, imagine x was 3. minus 3 is greater than minus 6. But positive 3 has to be less than 6. Okay, so if we just think about how numbers work, we can see that that has to be the case. Does that help you answer your question, Winston?
I don't understand what you're saying there, sir. I really don't. I'm confused right there, sir.
Okay, let me try that one more time. So what I've done from here is I've basically taken this minus 1, I've taken this minus, and I've essentially just times by minus 1. Okay, because I want to go from minus x to positive x. And to do that, I can multiply by minus 1. So I'm going to have to multiply by minus 1 on this side as well. So I've got minus 6 times minus 1, which is 6 there.
Right.
And because I've multiplied by a negative, I must flip the inequality sign. That's the rule here, okay?
Okay, that's true. I can understand now that you said that is the rule. Okay, because okay, that's fine.
Let me just put that up so you can sort of make a note of that. So the rule basically is if you ever multiply or divide by a negative, you must flip the sign. That's something really important to remember. And I'll show you another example of that in a moment, okay? So here's just my triangle. It's hard to explain, but it's easy to see if you look at number lines. If minus x is less than 1, then x must be greater than minus 1. Let's imagine we've got a number line. And here's 0, so here's 1. So let's imagine x is 2. So minus 2 is going to be less than 1. We know that. If I find minus 2, it's less than 1. Then the positive of it, then 2 has to be greater than minus 1. Okay? Hopefully that helps it a little bit. Okay? So 2 would have to be greater than minus 1 there. Okay? So always flip the sign when you do this. If you're really unhappy with that, then you have to make sure that you do your equations the first way round that I showed you so that you don't have to flip the sign. But generally, if you remember this rule, it's just easy to do, okay? So let's have a look at an example. If minus 2x is greater than or equal to 5, then we would have to solve this by dividing both sides by minus 2. So that means that x would have to be less than or equal to minus 5 over 2 because we've flipped the sign. So there's an easy example. Let's have a more complicated example. So here we've got minus 2x minus 1 is greater than 7. First step here is going to be to add 1 to both sides. So if we add 1 to both sides, we've got minus 2x is greater than 8. Next step is going to be to divide by minus 2. But because we are dividing by a negative, we must flip the sign. So only when we multiply or divide by a negative do we flip the sign. So now we're going to have x is less than minus 4. Does that help? I hope that helps. Hope that hasn't been too, sometimes students that I teach just find this a little bit tricky at first, but it tends to get easier. And if you do find it tricky, but you can remember that rule, you're normally okay. All right, negative numbers can be a little bit mind-boggling sometimes. So hopefully that's okay. All right. One more thing I want to talk about on the GCSE syllabus is combined inequalities. So we talked a little bit about combined or bounded inequalities earlier, but here we have one that's a little bit more tricky. And sometimes if they are a bit tricky, you could just go ahead and do this, but sometimes you will just be easier just to treat it as 2 separate problems. And so you might just think, actually, I don't want to do this all in one go. I might just take this as 2 things. And I'm going to solve this problem here where I've got 6 is less than or equal to 2x plus, or 2 times x plus 1. And then I'm separately going to solve 2 times x plus 1 is less than 12. I'm just going to split them up and solve them separately. So let's have a go at doing both of those. Oh, in fact, I think I'll do this with my pen. So here we've got the bracket, and there are two methods. We could expand the bracket if we wanted, or we could just go ahead and divide both sides directly by 2. I'm going to do the lazy option. I'm just going to go ahead and divide both sides by 2. Okay, so 6 divided by 2 is 3, is less than or equal to, and then this 2 has gone away. So we've got x plus 1 there. Now I'm going to subtract 1 from both sides and minus 1 from that side. 3 minus 1 is 2, less than or equal to x. So x is greater than or equal to 2 there. And then here we have got I'll expand the brackets this time just so you can see the two different methods. Why not? So I'm going to expand the brackets. I'm going to do 2 times x is 2x. We did this a long time ago, so hopefully you can remember this. 2 times 1 is plus 2, and that is less than 12. Okay, so this time I've got the brackets expanded. My first step is going to be to subtract that 2. Oh, sorry, it's minus 2 from both sides. And we've got 2x is less than 10. And then here I'm going to have to divide by 2. So I've got x and divide by 2 on both sides is less than 5. Okay. And really important here that we have a look at the problem. I've got x is greater than or equal to 2, and I've got x is less than 5 there. Okay. So my answer, my final answer will be, or should be, 5. Sorry, 2. Didn't do that right, did I? 2. Try that again. Let's choose a different color. There we go. 2 is less than or equal to x, which is less than 5. And I won't draw that on a number line because I think you've probably got that by now. But hopefully that helps. Okay. So let's just move that through. Okay. Right. I wanted to have a look at a couple of problem-solving questions before we run out of time, hopefully. But I just realized that I've gone a bit far. So we've got this question here. The width of a rectangle is 20 centimeters. What must the length be if the perimeter is at least 180 centimeters? Now, if you have a question like this in an exam, I'd highly recommend that you actually visualize it. I think visualizing really helps. So draw yourself a little rectangle somewhere on a bit of space on that exam paper. They'll probably have given you plenty of space to do that. Okay, so the width of the rectangle is 20. So let's put 20 on the width, and 20 is going to be on that side as well. And then we have to find what the length is. So the length is going to be this bit. So I'm going to put an X there, and I'm going to put an X there because those are my lengths and I know they're the same. And then the perimeter is at least 180 centimeters. So this is where I would be forming an I can't say equation here, an inequality. It's not an equation. They're not equal. They are. It's an inequality. So I'm going to be forming this inequality. I've got 20 plus 20 plus x plus x. Don't forget the perimeter is just adding the lengths around the outside, okay? So 20 plus x plus 20 plus x will give me that perimeter. And I need it to be at least 180 centimeters. So there we go. I've formed this equation, inequality. Now I'm going to solve this inequality. So the first thing we're going to do is simplify. So 20 plus 20, we can do that maths. We've got 40 plus x. So that's x plus x, which is 2x. And then is greater than or equal to 180 there. Okay, so I've simplified it. Now I can begin to solve. Start then by subtracting 40 from both sides. Okay, so I'm going to need to get rid of that 40. So I now have 2x is greater than or equal to 180 minus 40, which is 140. And then we've got to divide both sides by 2. By the end of this, you'll all be so good at solving inequalities. X is greater than or equal to then 140 divided by 2, which is 70 centimeters. Any questions on that one? Okay, right. And I think I've got time to do my last exam style question that I wanted to look at, which is a bit more tricky. Oh, actually, yeah, I should just show you that. It said at the end there that the length must be at least 70 centimeters. Okay, so just make sure you use the same wording in the exam question. It said find the sort of least value. So you need to make sure you continue with that wording. And here is my last question I want to look at with you today. We have got a cuboid and it says all measurements are in centimeters. X is an integer, so X is a whole number. The total volume of the cuboid is less than 900 centimeter cubed. Okay, so show that X is less than or equal to 5. So this one's a bit more tricky because it's kind of got a bit more like, you can't just form and solve an equation or an inequality here. We have to think a little bit more about what we're doing. The first thing we need to look at is what have we got here? We've got a cuboid. So basically means that this is just like a right-angled rectangular prism. And the volume of the cuboid is less than 900 centimeter cubed. We haven't done volume yet. That's going to be next month, I think. But to find the volume of a cuboid, you just multiply the height, the length, and the width together. So the volume of a cuboid is the height times the length times the width. So that is going to be the height, so that's X, multiplied by the length, so that's 3X, multiplied by the width, which is 2X. So using our algebra skills, we have got X times 3X times 2X. So we're going to have to do the numbers first. We've got 1 basically multiplied by 3 multiplied by 2, so that is 6. And then X times X, which is X cubed. Okay, so 6X cubed. So the volume is equal to 6X cubed. So the next thing we're going to do is we're going to look here. The volume of the cuboid is less than 900 centimeter cubed. So we can write our inequality now. We know that 6X cubed is less than 900. So now that we have our inequality, we're going to have to think about solving it. So solving this inequality, we're going to start by dividing by 6. Okay, divide both sides by 6. And we've got to the point where we've got X cubed is less than 900 divided by 6, which I feel like I should be able to do without a calculator, 150. Okay. And at this point, we're basically not having to actually solve it here. You could solve it, but if we look back at the question, which I've just hidden, it says show that X is less than or equal to 5. Okay, so all we need to do is basically show that X cubed is less than, if X cubed is less than 150, X then is going to be less than 150. And how do we take the inverse of a cube? It's a cube root. Okay. And all we need to do is show that the cube root of 150 is, I've lost it again. Sorry, my pen's going funny, is more than 5. Okay. So what we need to do now is we need to consider our cube numbers. And you should know your cube numbers, but 5 cubed is 5 times 5 times 5, which is 125. And so we can see there that this is definitely less than 125. Okay. So X is definitely less than 125 cubed root, And 6 cubed, 6 times 6 times 6 is 216, I think, which is more than. Okay, so 150, what we would write here in the exam, x cubed is less than or equal to 5 cubed, but x cubed is greater than 6 cubed. Okay. Sorry, x cubed is not greater than 6 cubed. It's less than 6 cubed because it's 216. Keep doing that. Okay, so any number less than, so 1 cubed, 2 cubed, 3 cubed, and 4 cubed are all less than. So that all fits into this x is less than or equal to 5. But as soon as we get to 6 cubed is 216, which is greater than 150. So this then is not possible. Okay. So I hope that's made sense at the end there. Probably the easiest way to do it is just to say that x is less than 150 cubed root, which isn't a whole number.
Excuse me.
Yes.
You said that the question asks you to show that x is less than or equal to 5.
Yes.
Cube root of 150, isn't that more than 125 is not the same as 150. If you were to take the cube root of 150, how much would you get? I don't have a calculator in front.
Oh, yes. That's what. So the cube root of 150 is 5.313. Okay.
Okay.
Yes.
Okay.
And so it cannot be 5.313 because x is an integer and an integer is a whole number. So the smallest whole number below 5.313 is 5.
Okay. Okay.
Yeah.
All right. That's
So
okay.
that means that it could be, but it could actually be any whole number that's below this. So it could be 1, 2, 3, or 4, or 5.
Okay.
Okay. So hopefully that makes sense. So it's a bit messy there. Okay. Any questions before we turn the recording off? Anything that you think would be useful for the recording? No. Okay, then what I'll do is I will stop sharing there and I'll turn the recording off. And then you can ask any other questions that you might have.